All right, so we will go ahead and get started. Welcome to this afternoon's first panel on Arctic navigation and shipping. My name is Emily Prince. I am a second-year law student here at Tulane and this year's chair of the Environmental Law Summit. Additionally, I'm a member of the Tulane Maritime Law Journal, so these issues this afternoon are very close to my heart. I would first like to thank the Tulane Maritime Law Center for sponsoring the three panels this afternoon. Before we get started, I just wanted to remind everyone that if you are attending this for Professor Houck's class, please sign in up here on the white sheet, and if you are here for CLE credit, you must sign in on the pink sheet before the session ends. First, let me welcome Professor Martin Davis. Professor Davis is the Admiralty Law Institute Professor of Maritime Law and serves as the Director of the Maritime Law Center here at Tulane. He's taught all over the world, including Australia, England, Singapore, Italy, and Greece. He also serves on the editorial board of Lloyd's Maritime and Commercial Law Quarterly. Professor Davis attended the University of Oxford and received his JD from Harvard University. Next, I would like to welcome Dr. William Drennan. Dr. Drennan is an associate professor of ocean sciences at the Rosenstiel, is that correct? Rosenstiel School of Marine and Atmospheric Science at the University of Miami. Dr. Drennan received his PhD in applied mathematics from the University of Waterloo. His current research focuses on processes at air-sea interface and includes aspects of both climate change and hurricanes. He also has an interest in development issues, having served on the board of directors of the Development Agency of the USC Canada. Please join me in welcoming today's panelists.
Good afternoon, everybody. It's a pleasure to be here. I usually feel a little bit awkward about thanking the sponsors, but on this occasion, thanks very much to the Tulane Maritime Law Center, of which I am the director. My task is quite simple. Which is to explain to you some basic information about Arctic shipping. Arctic polar shipping would be an inaccurate description because I'm only going to talk about the north, not the south, because there's not really very much commercial shipping in the Antarctic other than cruise ships. So my task is just to describe to you like what's happening and also to at least sketch out for you some of the issues from a maritime law point of view that are involved with Arctic shipping, and then William's going to talk about the environmental impact of this. So my outline is I'm going to focus mainly on cargo ships. As I'll show you in a moment, the principal use of the polar north in commercial shipping is in something that's called the Northern Sea Route, which is across the top of Russia and Siberia, and at the moment it has more than 50 cargo transits per year, many more than there used to be because of the receding of the polar ice. And there are very good data available from Russia's there is an official body, which I'll describe in a little while, called the Northern Sea Route Information Office. And they provide very good data about transits through the Northern Sea Route. The Northwest Passage, which is through, I'll show you in a moment, which is basically over the north of the United States and Canada, is still not really commercially used, although there have been commercial transits through the Northwest Passage. So I'm mainly going to talk about cargo ships. I'm not going to talk about oil and gas exploration in the polar north, although that is obviously a very big issue as well. But that's, well, there's not time for that, and that's not really my expertise. Of course, the other vessels, commercial vessels that use the polar north are cruise ships. And I would like to say a little bit more about cruise ships, but it's much more difficult to get data about cruise ships. The principal location for cruise ships using the polar north, principal locations are Alaska and Greenland. But as you can see on my overhead here, there is this body called Statistics Greenland. I don't know whether it's a body or whether it's just a person, actually. But their latest report was 2008. But in 2008, just to use the latest numbers available, which is quite a long time ago, there were 42 cruise ships visited Greenland in 2008. 28,891 passengers, which is significant when you think that the population of Greenland is 56,000. So, but I'm not going to say very much about cruise ships simply because it's kind of difficult to get information about cruise ships. So mainly what I'm going to talk about are cargo vessels using the Northern Sea Route. That's the principal focus. The use of the Northern Sea Route has really increased over the past 10 years, and there's a simple reason for that, which is the recession of the polar ice. So some basic information about the Northern Sea Route, which is my main focus. The navigation season for the Northern Sea Route, and I'm going to show it to you in a moment, now begins at the beginning of July, and it lasts through to the second half of November. That's about 4.5 months. In 2011 was the longest season on record for the Northern Sea Route, and in 2011 the Northern Sea Route was navigable for large vessels for 141 days. Now that's less than half of the year, but that season, that navigational season, is expanding every year because the ice recedes every year. In September and October, which is kind of the peak of the season, the Northern Sea Route is completely ice-free. It's open sea, which means, quite importantly, for reasons that I'll show you in a moment, that ships can sail at full cruising speed on that route because, well, there's no sheet ice. There may still be icebergs, an issue that I'll talk about in a bit. But at the beginning and the end of the season, as it says on the third bullet point, at the beginning and the end of the season, it may be necessary for ships to use icebreakers, which obviously increases the cost of the transit. But for much of the season, it's not necessary for ships to use icebreakers because the sheet ice is either absent altogether or is sufficiently thin that ice-strengthened vessels can simply sail right through it. Right? That's quite a long chunk of the year that the Northern Sea Route is open. It's actually about the same period of time that the Baltic Sea is open for navigation. Now, ships transiting the Northern Sea Route need a permit from the Northern Sea Route Administration of Russia. My colleague Gunther Handel, who's sitting right here, is going to, I think, talk in the next session about the international law, like which country is, which countries have the power to regulate polar passages. But certainly for any ships passing through Russian territorial waters, which, as I'll show you, are many, the Northern Sea Route the Northern Sea Route Administration has to give a permit. Right? So you have to apply for a permit. You can do it online. In fact, we could do it online now, but we don't have time. And there are compulsory ice pilots. Now, what an ice pilot is what it sounds like, is a pilot with experience in navigating in conditions of ice, particularly icebergs as well. So this is a compulsory pilotage transit. Most compulsory pilotage transits are because the pilot is needed to sort of know the lay of not the land, but the water. In this case, it's because of the conditions of ice. And just to give you an example, I'll show you this port in a moment. I actually didn't put it on the overheads that I'm about to use. But the port of Murmansk in Russia is very important, and I'm going to show you when we get to the maps. The port of Murmansk, there are two big ports. Well, one's much bigger than the other. Murmansk is a big port. There's another port in the east of Siberia called Pevek. And those two ports kind of open up the sort of heartland of Russia, well, Russia and Siberia, to world trade. And cargo turnover in the port of Murmansk doubled from 2003 to 2011. And that is entirely because of the increased use of the Northern Sea Route. So Murmansk is becoming increasingly important to Russian trade, and I'll show you where Murmansk is in a moment. So just to explain a little bit about the economics of the Northern Sea Route, what I'm about to show you is why it's important for sort of global trade generally. But if I can wiggle my, I didn't identify it on my map, but if you can see my wiggling cursor here, Murmansk is here. Can everybody see that? Maybe there's a pointer on here. There's a pointer on there. So we'll have to do with the wiggling cursor. If you can't see the wiggling cursor, then Murmansk is here, which means that, as I said, the Russian heartland here can bring goods through to the port of Murmansk and then be shipped out. Now, Murmansk, very interestingly, is ice-free all year round. The other main Russian port, at least on the west side of Russia, is St. Petersburg, which is here, again, if you can follow the wiggling cursor. St. Petersburg is not ice-free all year round. The Baltic freezes in the winter, and so Murmansk has a larger shipping window, than does St. Petersburg, and most of the cargo historically from Murmansk would go out into the Atlantic. But now increasingly the cargo coming out of Murmansk goes through the Northern Sea Route. Pevek, the other port that I mentioned, is over here, and it does, historically Pevek was not a very important port, but it's becoming increasingly important because it performs the same function of opening up Siberia to world trade. The other port in the east, of course, is Vladivostok. But if we leave Russia and Russian trade out of the picture for the moment, just in terms of trade that really has nothing to do with Russia, the economics of the Northern Sea Route make it increasingly attractive, but what I'm also going to explain to you are some of the reasons why it's not so attractive. But if we picture a voyage here from Rotterdam, the largest port in Europe, to Shanghai, the largest port in China, and if you go by the Suez Canal route, which is the traditional route, well, that's what it looks like. And the total voyage passage of the traditional route from Rotterdam to Shanghai would be 19,550 kilometers. The traditional route, and I have here the traditional issues. This is kind of pirates. Pirates are not as much of a concern anymore in the Gulf of Aden because we seem, touch wood, to have passed the peak of pirate attacks in the Gulf of Aden. But it adds to the expense of a passage through the Gulf of Aden, because one of the reasons why pirate attacks have decreased in the Gulf of Aden and the Indian Ocean is because vessels now routinely have armed guards aboard. But the traditional route includes Suez Canal fees, which for a large container ship will be about $100,000, and the cost of what they call stiffening the vessel for its passage through the Gulf of Aden. The ship for this transit would also have to stop for bunkers. I'll talk about bunkers a little bit more in a bit. Bunkers are the name for the fuel oil that ships use. You can't make this transit without filling up with gas, basically. And, I have here a stop in Singapore, the most likely bunkering port on the way. So it's a long way, and it costs a lot of money. And I don't know if you saw what just appeared down here, in 2013, about 17,000 container ships did that transit. The Northern Sea Route, on the other hand, well, obviously it goes the other way. You can see it goes around the north of Norway, And then this is an issue which I should point out. This island here is called Novaya Zemlya. How did I do, Anton? Great. Anton's Russian. Novaya Zemlya. It's actually two islands, although it doesn't look like it. And in between those two islands, there's this deep sort of trench of a passage called the Matochkin Strait. This has got nothing to do with what the topic of it. But the Soviet Union used to, and Russia now does, do all its nuclear testing in the Matochkin Strait, which is kind of here. But the reason for pointing out Novaya Zemlya is that as the season progresses, ships can go north of Novaya Zemlya, which reduces the passage time even more, because as the ice recedes, you can come straight up and over the north, which cuts off some of the transit time. This has the vessel going south of Novaya Zemlya, which is produces that passage time. Just to point out again, this is where Murmansk is. Ships coming out of or into Murmansk always go south of Novaya Zemlya. That's a saving of 3,700 kilometers, and that's a real saving in terms of time and bunkers. And I mentioned bunkers before. Bunkers is the fuel oil that vessels use, and the cost of bunkers is increasingly important to ship owners. Years ago, the cost of bunkers would be about 5% of the daily running costs of a commercial vessel. Now it's about 25% of the daily running cost of a vessel. You may think that the bunker costs are going down because the cost of crude oil is going down. That's actually for reasons that we don't have time to discuss. There's not much of a flow-on effect to the cost of bunkers. So bunkers are very expensive, and to be able to have a transit that will save that much in terms of bunkers makes it much, much more commercially attractive. Now, how many container ships did that in 2013? One. Right? So in terms of container ships, not so much use of the Northern Sea Route. But as I'll show you in a moment, the main use of the Northern Sea Route is actually by tankers, which has a particular significance for environmental concerns, because, of course, tankers bring with them increased concern about pollution. So most of the traffic on the Northern Sea Route so far is tankers. And there is, as I mentioned before, I mean, there are dangers here too. There's a danger of icebergs. Not sheet ice, but I mean, it's never completely ice-free. There's a danger of icebergs there, which is why you need an ice pilot. The Northern Sea Route is not always the shortest route. I've got some examples here. I mean, essentially, the further north you go in Europe or Asia, the shorter it gets, right? But if you're leaving from or going to a port further south in Europe or Asia or the west coast of the United States, well, then it gets longer. And so just some examples here. London to Yokohama, much, much shorter by the Northern Sea Route because they're both fairly north. Rotterdam, Shanghai, New York, Shanghai. But the further south you go from leaving to arriving, well, then it's not. And so no ship would contemplate taking the Northern Sea Route for the kind of voyage in the bottom half of the screen there, Rotterdam to Singapore, for example. Northwest Passage, well, I'll show you. I mean, the idea is basically the same in relation to the Northwest Passage, but this is not so commercially used at the moment. If we do Vancouver, either Vancouver or Seattle to Rotterdam, you go through the Panama Canal. That's about 16,400 kilometers. Again, the canal passage alone will cost about $80,000. And if you go the other way, it involves going through the north of Canada. Again, you save about 3,550 kilometers on that transit. That passage is not open for as much of the year, though, because those waterways are between islands and less open sea. They freeze for more of the year. So the season is not as long, and it's just not as commercially developed as the Northern Sea Route is. If you want to think of going the other way, the Northwest Passage, if you're going from Shanghai to Rotterdam, and of course I don't have that on my map, but Shanghai on the other side of the Pacific, Shanghai to Rotterdam through Panama rather than through Suez would be 25,000 kilometers. If you do it through the Northwest Passage, it will be 17,000 kilometers. If you do it through the Northern Sea Route, it's 15,000 kilometers. So the point of pointing that out is, if you're talking about Europe to Asia trade, the Northern Sea Route is more attractive than the Northwest Passage. Okay, but the first commercial transit on the Northwest Passage was made in October 2013. 75,000 DWTs, deadweight tons. That's the quantity of cargo that the ship is carrying. 75,000 deadweight tons. That's a big ship. 75,000 deadweight tons. The bulk carrier, Nordic Orion, sailed from Vancouver to Finland, and the owners estimated it saved them about $80,000. And the Panama Canal fees, which would be another, well, for a ship that size, possibly more than $80,000. Okay, well, what I'm now going to do is to talk about the insurance issues, which are a very important thing for maritime commerce. And you see the caption to this slide is "Hull underwriters don't like ice." But in order to sort of explain what I'm about to do, I need to tell you a little bit of basic information about the way ships are insured. Ships have two different kinds of insurance. They have hull and machinery insurance, which is insurance on the ship itself, like you have insurance on your car. And what hull and machinery insurance covers is obviously the hull itself, the ship itself. And hull and machinery insurance is usually placed with commercial insurers, either directly at Lloyd's of London or very often with a commercial insurer that reinsures at Lloyd's of London. And that's sort of commercial profit-making insurance. In terms of liability, the ship's liability exposure, that's not placed with commercial insurers. That's placed with things called P&I clubs. Protection and indemnity is what P&I stands for. And why they're called clubs is that they're mutual self-insurance associations. So these are ship owners insuring themselves, basically, by paying into a mutual pool. And they act very differently from the way commercial insurers do. P&I clubs' tendency, the P part of protection and indemnity is protect. Right? So their instinct is to protect the ship owner and to pay the claim first, to ask questions later. As you probably all know, that is not how commercial insurers act. Right? So we have two different types of insurers that we need to be concerned with in terms of just... because without insurance, these transits are not commercially viable. And just with this slightly better map, I can show you again, if you can see the wiggling cursor. This is Murmansk, here's Novaya Zemlya, and you can see why ships from Murmansk go south of Novaya Zemlya, and ships coming from the North Atlantic, it's easier to go north of Novaya Zemlya when the season makes that permissible. And then the ships have to pass through close to the northern coast of Siberia and then through the Bering Strait. And then either to the west coast of the United States down here or down to Asia. Now, hull underwriters don't like ice. The hull insurance policies are always expressed to be subject to something called the Institute warranty limits. And what the Institute is the Institute of London Underwriters in London. And they have always stated what they call warranty limits, which is basically we'll insure you for risks, any risks to the hull, well, kind of almost any risks to the hull, to the ship itself, but within defined geographical limits. Because if you go outside these geographical limits, then you're entering into territory that's more risky and that we don't want to cover. And what you see there is what the Institute warranty limits are. Right? So anywhere above 70 degrees north, and there is actually an exception, as you can see down here. The Institute of London Underwriters does make an exception for northern Norway, but basically anything further north than 70 degrees north is excluded. And there are specific exclusions that actually go much further. Include, well, you can see what it says in the map. And so there's not a lot of the Northern Sea route that the hull underwriters will cover, will normally cover, and none of the Northwest Passage is covered under the ordinary Institute warranty limits. Now what that means is, for a ship that wants to use either of these passages, they will have to buy a special policy to cover that transit. Right? They will have to buy a special insurance policy to make that because no ship is going to engage in a commercial transit if it doesn't have insurance. Now, I wish I could tell you with some degree of accuracy how much a single voyage premium would be. It's actually very difficult to get that information. If you ask an underwriter to give you a quotation for a 50,000-ton ship or whatever, they'll say, have you got a 50,000-ton ship? And I say, no, right? They say, well, I'm not going to tell you that, right? Because they regard this as kind of commercially sensitive information. But, and so even if I could tell you, it would be anecdotal, and this is something short of anecdotal, but I think it's about $50,000 per transit. Right? So that'll be a $50,000 premium for hull cover for a single transit. It may well be more than that, it may well be less than that. But the key point is it's going to be a good deal less than the cost of the canal transits. Now, some statistics. I had already prepared this graph and this chart, and then just the other day, the Northern Sea Route Information Office released its figures for 2014. So I had this table filled out for 2013, which was the latest available information. They've just released the 2014 information, but not completely. So this chart is kind of a hybrid between comparing 2013 and 2014, and some of it is 2013 only. But as you can see, the principal ships, the total number of vessels, the largest number of vessels using it, and it divides it between eastbound and westbound. There were 31 tankers in 2013, 27 in 2014, 13 general cargo versus 15 in 2014, 71 total transits in 2013, 54 total transits in 2014. Now, we don't have the tonnage numbers for 2014 yet, but in terms of deadweight tons, that's 1.8 million deadweight tons. That's a lot of cargo. I mean, it's not anything like as much cargo as is going the other way, but that's a substantial quantity of shipping now. Between 2012 and 2013, that jumped 58%. It was 45 in 2012. It went up in 2013, down a little in 2014. Cargo volume's about the same, though. And here's an interesting thing in terms of possible environmental impact. How many casualties have there been inside the Arctic Circle? Well, between 2002 and 2007, there were only 7 casualties inside the Arctic Circle. Between 2009 and 2013, 45 casualties inside the Arctic Circle. So the increased traffic, it's always the way. I mean, it's the way with traffic in roads as well. The more traffic there is, the more casualties there are. Here's a brief sort of map. This won't take me long, not least because I don't have very long left. Shows you the search and rescue responsibilities. This is of particular significance in relation to passenger vessels. The SOLAS Convention, the Safety of Life at Sea Convention, requires passenger vessels to be able to evacuate the ship completely within 30 minutes. And I always think about cruise ships going up to the Arctic. Well, that's brilliant. If you can get off the ship in 30 minutes, you'll be in the lifeboat within 30 minutes. Then what's going to happen, right? And the answer is the search and rescue, a country, as denoted by this map, will have search and rescue responsibilities, but that search and rescue is going to take a long time to get there, depending on where you have your problem. Right? Okay, now just in the few minutes that remain, to describe some of the stuff that I think about, which is the commercial operational issues in relation to the ships themselves. And remember, hull insurance is the ship itself, right? It's not the liability. And the default position, as I told you before, for hull and machinery is that there are no issues because there's no cover, right? You have to buy yourself extra cover, and the extra cover may be limited in the sense that it may have more exceptions than a hull cover would normally have. Is there more risk? Well, yes, there is. Because the typical kind of hull insurance problems are things like what I've got on the screen here: engine breakdown, a grounding or a stranding, hull damage, heavy weather or fire. If you just picture it, all of those become much more difficult when you're that far away from assistance. Extreme cold can add to the engine problems because the oil begins to become gelatinous and doesn't pump so well. It has to be heated in order to make it pump. A couple of issues that you might not have occurred to, but is actually quite important. The navigation aids. Ships increasingly use the computerized navigation aids like GPS. Well, that doesn't work very well up there either because there are no satellites giving you the feed, so navigational aids don't work so well up there. It's not very well charted because until recently it wasn't a frequently used cargo route. Compasses don't even work very well in the polar north because of the high latitudes. It's restricted visibility much of the time, particularly in the end of the season, October, November. It can be dark almost 90% of the time. The day gets very short, right? The weather reports, there are very sophisticated weather routing services for the rest of the world, but they do not cover the Arctic North. Violent storms anytime, and of course ice. Now, a big issue in terms of the hull itself is salvage facilities. If a ship gets into trouble, it needs a tug to come and sort of render its salvage assistance. And in most of the world, they're a little bit like tow trucks. In fact, they're quite a lot like tow trucks. They kind of wait around with very expensive equipment, and if something goes wrong, then they come and help you, right? Well, up there, they're a long way away. Right? The icebreakers that accompany commercial vessels at the beginning and end of the season, they're not salvage vessels. They're icebreakers. So they're not equipped with the equipment that a salvage tug would be equipped with. What was that?
Oh, just like for... you have extra time.
Right. It's okay. I mean, I want to not run over my time here. So although icebreakers are support vessels, they're not salvage vessels. They're not equipped with the equipment that a salvage tug would be equipped with, and conversely, a salvage tug is not equipped with icebreaking equipment. And there are very few salvage support vessels for thousands of miles, and particularly if you think about it, in the eastern Northern Sea route, when you're talking about Siberia, you're on your own out there, right? This is going to factor into the underwriting decision made by the hull insurer, how much they're going to charge for this transit. Even if salvage equipment could be performed, that's a tough salvage up there, dark and inhospitable conditions. And just some details, again, I don't want to get into too technical stuff, but when a casualty has occurred, there are some things that are routinely done by the salvors including underwater surveys to see whether there's damage under the hull. We'll just picture that's pretty difficult in those conditions. You may need to pump water out of the ship's hull. That doesn't work very well in the north either. Lightering. What lightering is to take some of the ship's cargo off onto smaller vessels so that the ship then becomes lighter. It's lightering. You don't have lighters available either. Lighters being the vessels that come in, the smaller vessels that come and take the cargo away. That's probably not an option. Temporary repair facilities. What very often happens after a casualty is you take the vessel into a temporary port for temporary repairs, and then it goes on for permanent repairs elsewhere. There's nowhere to do temporary repairs up there. So it'll be a race against time to prevent the vessel from sinking. Well, depending on how bad the casualty is. Okay, some P&I issues. Again, the default issue for P&I cover, liability cover, is there aren't any issues because there aren't any cover, right? But for a slightly different reason. P&I clubs, the Protection and Indemnity Associations, the mutual self-insurance associations of ship owners, do not impose navigational limits in the way that hull insurers do. I showed you that map before with the hull cover picture. P&I clubs don't care where you go, but they want you to tell them where you're going. And this is part of the really sort of deeply ingrained notion of mutuality that there is in P&I clubs. They act on the basis that we're all ship owners. Right? We're all doing this. We're all in this game together. The notion of mutuality is very important to them. And so the club will say, we will provide you with cover, but don't be doing anything behind our back. Right? It's fine if you tell us. It's not so fine if you don't tell us. Right? So the club cover, I mean, I don't know why I included GARD as one of the two Norwegian P&I clubs. By the way, another small sort of fact that non-maritime people may not know, there are really only 13 P&I clubs in the world that are all members of this thing called the International Group of P&I clubs. So over 90% of the ships in the world are entered with one of 13 clubs. And GARD is one of the two Norwegian clubs. That's GARD's Rule 7 is their rule. You have to consult the club if the vessel's not falling within the normal trading pattern. Now, is there more risk of liability? Well, yes, of course there is. The club is responsible for wreck removal. The hull cover covers damage to the vessel itself, but if the vessel sinks and has to be removed because it's a hazard to navigation, that is the club's responsibility. And wreck removal just picture it in the frozen north, is going to be much, much, much more expensive. By the way, just to give you an example, I'm sure everybody's heard about the Costa Concordia, and they talk about the salvage of the Costa Concordia. Well, that wasn't salvage, it was wreck removal, and it's not just pedantry to point that out, because if it had been salvage, it would have been paid for by the hull underwriter. Because it was wreck removal, it was paid for by the P&I club. For environmental salvage, for the efforts of the salvor to protect the environment, those are paid for by the club, not the hull underwriter. And that can obviously be significant in that territory. Wreck removal is going to take a lot of time and equipment. Oil pollution, huge problems in the north. The cold temperatures and the ice affect the behavior of the oil in many ways. It becomes much more persistent because of the cold. It's my last one, right? And oil can get trapped under the ice or be held within the ice. And then it melts months later, and then all of a sudden you have an oil slick. The booms that are used to prevent the spread of oil often don't work because of the sea state. Burning, as in the Deepwater Horizon, doesn't work very well in that environment either. And actually, even spotting where the slicks are can be difficult because it's dark for so long. And the other thing, I mean, there has not been a major spill in those latitudes to date, but what is still not well known, because it hasn't been all that much tested, or at least I believe it hasn't been all that much tested, is whether the chemical dispersants that are used and were used very much in the Deepwater Horizon, it's not at all sure how they work in low temperatures either. So there are lots of technical issues in relation to oil pollution that make the oil pollution risk much higher as well. Now, the club will not charge an additional premium. What clubs don't call them premiums, they call them calls. They'll not charge an additional call to go through that transit. But they'll want to know that these are the additional risks that they're being exposed to. And if the member is going to routinely use that trading pattern, then their annual call is going to be that much the greater. And I believe, political environmental sensitivity. Actually, I didn't plan it to be a segue, but that's the end for me. And over to William. Oh, sorry. You want me to leave that up?
I'll just comment one on yours, and that's the detection actually is probably not as hard simply because synthetic aperture radars, which are used for detecting ice, could probably be used for detecting oil.
Right.
Because you're basically looking at the small scale smoothness. So that's the only one of these where there's probably some optimism that. But generally, thank you.
Oh, you want me to get you over there? It's yours on the... it's there. Okay. Get out your way.
Well, thank you. I enjoyed that very much. That's a whole lot of stuff that I don't normally see. So my perspective is going to be a lot different than a lot of the ones here. I'm a scientist. I don't have a lot of interaction with the legal community. So I was tasked to explain some of the impacts of climate change on the Arctic environment. So that's what I'll do. Although I'm working in Miami, I actually do work in the Arctic. Sort of work anywhere. We do anything to get out of the heat there. It's about as far away as you can go for that. 2007, I was on this cruise. There's been a lot of work lately to actually document what's in the Arctic. One of the problems with assessing how the Arctic's going to change in a changing climate is that we don't know what's there now. It's very difficult to get there in spring to do any of the assessments of what's there, because you basically have to break through the ice from one of the two sides of the Americas, from Alaska or from basically Baffin Bay to get in. And by the time you're there, you're basically well into summer. So there's been two recent cruises where the ships essentially overwintered up there. So they go up for 14 months. This is the Amundsen, and they basically leave in the June of one year and stay up till the September of the following year. So they're actually up there for the entire season. Obviously, the crews don't stay there that long. We get helicoptered back out typically every 6 weeks. But that's the way that we've been learning what's up there now, because there's definitely a strong realization that what's there now isn't going to be there for much longer. So the context, again, this is stuff that everyone's seen. It's official as of last month that 2014 was the warmest year ever recorded. And a report that came out just a couple of weeks ago from the National Academy of Science synthesizes a lot of what we now know and looks at some of the impacts are going to be. Sea level rising is one that there's been a lot of talk about. It's important in places like Miami. It's important places here. It's actually not as important in the Arctic. That was one of the topics that was in the discussion. That's partially because the Arctic is essentially it's basically still rising from the retreat of the glaciers after the last ice age. So much of the coasts in the Arctic are actually rising, even though sea level is also coming up. Ice sheets, of course, are what we're going to be talking about here. Glaciers, a totally different topic. Anyway, it's an interesting report if you're interested, so I thought I'd basically put that web page up. Again, there's no debate in the scientific community about what's behind the the climate change. And as long as this curve keeps going up, there's really not a lot of chance of stopping the trends in temperature. And just to put it in context, this is a fairly common graph for those in the climate community. People started measuring CO2 in the atmosphere about 1958, and this is one of the most important curves in climate science, in that it was evident almost immediately that carbon dioxide in the atmosphere is going up. And this now shows the last essentially 50 years. And to put it in the context of the last ice ages, this is the last 850,000 years of carbon dioxide. And we're measuring this using ice cores in the Atlantic. The carbon dioxide is the bottom curve. Our present levels are the red dot on the side. So we are well outside of an envelope of carbon dioxide that we've seen for at least the last 850,000 years. And we're getting that by looking at gas concentrations basically preserved in snow, which is accumulating on the ice packs in the Antarctic. So again, this is the temperature, the average temperature for the planet. What's of particular importance from the point of view of the Arctic is that the temperature increase isn't uniform. And it's significantly more by a factor of 2 in the Arctic. This is the 2014 temperature increase compared to an average. And you can see in the Arctic, it's often up to sort of 3 to 4 degrees Celsius, which is 6 degrees, probably Fahrenheit, warmer than it was being on an average, which basically is between 1950 and 1980. That's a lot. And that was 1 year. If we look at essentially the last 60 years, these are the trends. Again, the Arctic is showing up to 0.5 degrees C a decade, which means essentially since the 1950s, we're now about 5 degrees Fahrenheit warmer in the Arctic than we were. That's about 3 C. In fact, the winter temperatures haven't changed much. The summer temperature change is actually about twice that. So it's got really, really profound impacts on a lot of aspects of the Arctic. So some of the consequences, obviously one is Arctic ice, and the reason the Arctic temperatures are changing so much is tied into the ice, and I'll explain that in a minute. Shifting ecosystems, both marine and terrestrial, things are changing there really, really quickly. I'll talk a little bit about it from the marine side. We're seeing things that haven't been seen basically from what we can tell for sort of 800,000 years again. So there's now species moving in places they haven't been for a long, long time. Thawing of permafrost, I'm not going to talk much on that, but it's a threat to the infrastructure, and to some degree that stops us from being able to develop the infrastructure we need for shipping. Much of the coastal lands, areas like Alaska, are basically thawing permafrost, and they're becoming unstable. So not only is it difficult to build new infrastructure there, it's actually difficult to preserve some of the infrastructure we now have. This is a picture I took in the Canadian town of Inuvik, and the whole infrastructure there is designed, they're basically on gravel beds. This would be the sewage and water will be coming in from the top, so that there's no risk of any of the heat from the building actually melting through the permafrost. As the permafrost is now melting anyway, much of the infrastructure in the Arctic is no longer going to be viable. So there's going to have to be, in addition to the investment to build new infrastructure for shipping, there's also going to have to be a huge investment in much of the Arctic to basically re-engineer what's there now. Now that's not universal. There's parts of the Arctic which are built on rock. Much of Greenland is, for instance, and that's a lot more secure. But in the Western Arctic in particular, the melting of permafrost has got a significant impact for the infrastructure that's there now, in addition to much of the ecology. And I already mentioned about sea level rise. So ice, this is the ice last week up there. Really since the 1980s, we've been able to get daily images of ice. There are a lot of satellites there, basically specialized on ice, especially the polar orbiters essentially go over the poles each day, so we can get very, very good daily images. And this is a sort of typical current day winter. So there's two things about the Arctic ice that's important. One is that there's a natural seasonal cycle that goes up and down. It tends to peak sometime just about now, sort of March 1. And the low of ice is typically that sort of September, October window. In addition to the seasonal cycle, we also see some variability from year to year. So the red line here was last year. The black line is the average from 1980 to 2014. So you can see, and I'll show you that again soon, a gradual diminishing of the ice. It's true pretty much the whole year, but it's much more profound in the summer than in the winter. So this is the seasonal ice max and min last year. I don't think it's exactly the max because I didn't go through and see it, but it's basically roughly sort of early March. So this is a sort of typical modern midwinter. That's why we don't put boats there in the winter. And this was the minimum last summer. And that is now, as you'll see, becoming a sort of typical seasonal coverage. You can see the open northern route. And you can see the Northwest Passage is marginal. It wasn't fully open last year, but it's close. So these are curves of the ice coverage. The minimum winter is black. So that's the minimum of the maximum ice coverage in winter. The red is the summer ice coverage. And this goes back to the beginning of the satellite era. So we really don't have data going before about 1978. The only data we really have is actually submarine data. During the Cold War, both American and Russian submarines were frequently going under the ice. They've recently made some of their data available, and we now have an idea of the thickness of the ice and to some degree how much ice was there, and that'll go back to the 1950s. But you can see in particular on the red line the dramatic change over recent years. And you can also see the two spikes, 2007, which at the time was the first unaided transit of the Northwest Passage in history, and that was the ship, in fact, that we were on. One of my students got to do that. I don't think she knew exactly the significance of that. People have been trying to find the Northwest Passage for 400 years, and it's there. And in 2012 is the even steeper drop. So we're now in a very different regime than what we were pre about 1980, 1990. So this again, these are the winter coverage from the sort of heavy periods of the 1980s to last week. And we can see again there is a sort of shrinkage back of ice coverage, and that's on average about 5%. Okay? And this is summer. The shrinkage of summer from the present day summers, and this is not the maximum of 2012. This is the one last year, 1980. It's a decrease of about 40%. Other thing you can see a little bit is the color coding on this is the sea ice concentration. So these satellite pictures basically tell you whether there is ice in a window or not, and you can tell essentially how much ice is there. It's not simply binary. It will also tell you how much ice is in there. So there's less of the purple and more of the color. In addition to the concentration going down, I haven't got it on this plot, but the thickness of the ice is actually going down too. We tend to classify ice thickness by age. A 5-year ice is basically the thickest. A 1-year ice is the thinnest. After 5 years, it kind of maximizes out. But there's very, very little 5-year ice out there anymore. Most of the ice is now 1 to 2 years old. And the thinner the ice is, the faster it is to melt. So this is one of the feedbacks I'm going to be talking about. So why sea ice matters? The reason that the sea ice has started going down to the degree it has, and the reason why the temperatures in the Arctic are going up so much, basically relates to what we call the albedo. And that's how much of the incoming radiation from the sun is simply reflected back to space. The open ocean basically absorbs 95% of the energy coming in. It absorbs almost everything. Clean ice, or ice with a little bit of snow on it, is the opposite. It reflects about 90% of the energy right back out to space. And bare sea ice is about half. So as we remove the ice, essentially, as the ice melts back, more of the energy from the sun is being absorbed by the ocean. So that keeps more of the heat within the Arctic system that warms up the water. That warming up of the water makes it easier for the ice to then keep melting. As the ice melts, again, the albedo changes, so there's more absorption, and this is what we call a positive feedback loop. And that's why the changes of temperature in the Arctic are much, much higher than they are anywhere else on the planet, because it's coupled to the phenomenon of losing the Arctic ice coverage. As that goes down, more of the heat is basically absorbed by the oceans. That means that the freeze-up each year is a little bit later. It means the ice each year is a little bit thinner. And it means that the breakup of ice starts a little bit earlier. And so there's this feedback again that's tied into the albedo. So again, this is the way we tend to put it. As you reduce the ice, more ice melting, that reduces the albedo, or the reflectivity, which means that there's more energy absorbed. That results in a higher ocean temperature, which results in more ice melting, etc. And there's a bunch of different positive feedback loops in the climate system. This is probably the biggest. And this has got a very strong regional impact as well as global. One of the impacts of that is, or evidence of this, is we're starting to see significant increases in the summertime temperatures in the Arctic Ocean. So it's a little hard to see on this plot, and I'll show you another one. This is the actual temperature, and you can see basically the much, much warmer Pacific water and the warmer Atlantic water compared to the cold water. This is last summer versus an average from 1980s to 2000. And what I'm going to show you in a minute is what we call a temperature anomaly, which is the 2014 subtracted from the average. That way you can see how the changes are. It's a lot easier to see than something like this. So those are temperature anomalies. Again, this is the average August temperature from 4 different years, 2007, 12, 13, 14, minus the average of all the August over a 30-year period, 1982 to 2010. And you can see how, especially 2007 was the most profound, we're starting to see much, much warmer, up to 5 degrees C warmer water coming into the Arctic. It's a mixture of water coming in from the Pacific, but it's mostly local heating. And we're getting the same kind of feature each of these years. So the water up there is much, much warmer now in summer, which is one reason why the air temperatures there tend to have increased much more than anywhere in the rest of the planet. And of course, this results in a much later onset of freeze as well. Now, some of the consequences to the ecology are quite interesting. As the Arctic temperatures warm, we're starting to get a migration or an appearance of species which are traditionally found in the Pacific into the Arctic. And you can sort of see that almost the fact that the water mass going into the Pacific is similar now in temperature and properties to that in the Arctic. And it's allowing species to penetrate in. And one particular one that was interesting, this is a diatom, which is basically a small marine plant. These are microscopic. And this is traditionally found in the Pacific waters. And these are different data, basically, where they've been found. Starting about 10, 15 years ago, we're now seeing them in the Atlantic. They haven't been seen in the Atlantic, and we can go back using sediment cores. We can go back sort of millions of years. The last time they were seen in the Atlantic was about 800,000 years ago. So we're now starting to get species able to survive long enough through the Arctic. The conditions there are now warm enough that the much more temperate species are now able to basically survive. So the ecological impact on this for Arctic species is going to be very, very profound. As these ones move in, the essentially native species are in many cases being outcompeted. Some of the species in the Arctic they're basically adapted to very cold conditions. One of the main fish here is an Arctic cod that's about something like that big, very bony. They're not of all interest to be eaten by humans, but it's a main food source for everything from polar bears to a whole lot of different species because they have a characteristic that they're adapted for very cold water. They hardly move, kind of like teenagers. And they basically wait until it's time to eat, then they grab something and they go back to being sort of immobile again. But it makes them it makes it very, very easy for other animals to catch them. Well, they're now being outcompeted by some of the species coming out from the Pacific. So the follow-on to some of these changes are basically unknown. But basically, as the conditions change, Arctic species and mountaintop species will be the ones whose niches is basically essentially going away. So ecologically, it's probably not going to be good for a whole lot of different species. Whereas other species, like this one, will able to expand their habitat. This is a set of data. This isn't Arctic, but this basically shows the same kind of phenomenon. This is zooplankton species by groupage, and showing how different groupages of species have moved over basically from the 1960s, 70s to the sort of late 1990s. And the leftmost panel shows these species were traditionally the sort of southern ones. They were initially found off of France. Over that 20-year window, they're now being found much more frequently up off of Scotland. The next panel shows species which were traditionally found in the sort of English Channel into the North Sea. They're now moving, on the English Channel, they're now being found more and more in the North Sea. So one thing about the marine ecosystem is it's very mobile. It moves. And we're already seeing that. The Arctic species, which were basically evident on the 1960s, are pretty much gone from the picture now by the 1990s. They've simply moved further north. So the ecology is changing quite quickly, as are some of the fisheries. They've been keeping track of fish landed in London since the 1300s, and they're now getting fish that haven't been seen there sort of ever going back to the 1300s. So if you do a simple extrapolation of this curve, you get ice-free summers in around 2060. Obviously, given the variability of this, you can probably expect to see something approaching ice-free sometime sort of 2040. So within the lifetime of most people in the room, we can expect to start seeing some period of summer where it will essentially be ice-free. This is from the IPCC report, not the most recent one, but 2007. This is a fairly nice summary of the shifting. This is current Arctic conditions, and this shows not only the average ice, but it also shows where the permafrost is, which is the kind of light blue. The green is the boreal forest, and you can see by end of the century, the permafrost is essentially gone. Something like 80% of the permafrost, including most of that within continental North America, is gone. And of course, it's also got the two sea routes that we've been talking about. This is sort of projected duration. This was, I won't go into this. This is sort of the subject of the last talk. But I thought this would be an interesting one to sort of complement some of the points made last time. This is a picture of the Arctic population. There really is, especially on the North American and Eastern Siberian sides, a complete lack of infrastructure. A big town there is 15,000. Once you start getting into the far north, especially in the Northwest Passage, a big town is 800. There is no infrastructure up there. Once you basically get past the Alaskan coast and Nome, you're coming through, even though Resolute is marked there's nothing in Resolute. There is plans to put a Canadian base at the top of Baffin Island. Whether the government does something like that, Canadians are very touchy about sovereignty up there, and current Prime Minister has been looking to basically make a clear case for sovereignty by having some sort of base there. There's no mining town up there, and that's what they use. But essentially, if something happens in the north, there's very, very little chance of a rapid rescue up there. There simply isn't the infrastructure for it. Nuuk, Greenland, which is in the south western corner of Greenland, is probably your biggest place. Thule would be another possible. But really, it's very, very difficult at the moment, if anything happens, to contemplate what the evacuations would be. And with that means if there is any type of an accident, the degradation of oil up there is very, very slow. So the consequences, the ability to clean up after an accident are going to be extremely limited. The duration of the consequences are probably going to be very, very long. There simply isn't the infrastructure up there to actually deal with it. I had a plot up there on sovereignty. Unless there's issues, I won't go into that. But so summary, the Arctic temperatures are warming much faster than anywhere else, and that's really tied into the ice albedo feedback and the Arctic ice loss. We're expecting ice-free Arctic summers, sort of late summers, basically within 50 years, probably earlier. The navigation period is increasing significantly as a result. Although there's a lack of infrastructure up there to actually support it, and the lack of permafrost and the basically transition from a frozen soil to a thawed soil is going to make that more difficult. I haven't talked about ocean acidification. It's probably an even more severe threat to Arctic ecology than the rising temperatures, in that the ability of calcifiers to make anything with calcium carbonate is probably going away. Because much of the biggest ocean acidification issues are up there. But from the point of view of Arctic navigation, that is a sort of separate issue. So, thank you, and that's all stop.
I think I'm actually supposed to be the moderator of this panel as well. So, we have at least 20 minutes for questions. So, yes, let's begin.
Just a point on the
questions, comments
on the EPA rulemaking that's come up, and there's been some literature reviews on methodologies, and specifically dispersants and Arctic. And the upshot is of the Merv Fingus Environment Canada on dispersants is forget it. That's the short of it. EPA has even gone as far as banning them in fresh water. But the literature is showing that below about 50 degrees C, they don't work either. They just don't work. So the oil industry is doing all sorts of gyrations to try to make it look like they work, like including switching the tests around to apply much more energy to make it look like they work, like you have to have a hurricane, basically, to disperse. But then the other option is burning. And alarmingly, what EPA is proposing to do is allow jet fuel, diesel gas mixtures, and gasoline to be spilled on top of oil so that it may be burned. But the thing that when I saw that, because I lived in Alaska for 28 years, was where are they going to get that, given the infrastructure? And where they would be getting it from would be these native villages that basically have huge storage tanks. They get this fuel that's supposed to last 6 months in twice a year. So they'd be raiding. I mean, I can't wait to tell the Alaska Native villages about this.
I'm guessing they'll probably fly it in with tankers and just disperse it from the air would be my guess.
Well, anyway, it's just like
that'd be my guess.
Nothing's good.
So thank you. There was something else over here. Yes.
The main causes of the casualties, that the 45 or whatever, what was there some?
I don't know. That's just a statistic that I got from, actually got it from GARD, which is the Norwegian P&I club. They publish tables. My guess is, though, I mean, most casualties in sort of commercial shipping are collisions. I'm guessing it's not collisions up there. It'll be either a grounding or contact with icebergs, but I don't know. I mean, the source that I used that showed that it had gone from 7 to 45 is just numbers. I'm sure there's an answer, but I don't know. Yes?
Has there been any discussion within P&I clubs to consolidate salvage services?
To consolidate what?
Salvage services?
the short answer to that is no, because salvage is not the P&I Club's concern. It's the hull insurer's concern. What the P&I Clubs pay for are the efforts that the salvors make to protect the environment. At the risk of getting sort of more boring than you wanted me to be, historically the rule in relation to salvage has always been no cure, no pay. If you don't successfully salve the vessel, you don't get paid anything. Right? Which means that if the ship is sinking and the ship and cargo are sort of destined to be lost, all that salvors traditionally would do would be kind of wave it goodbye, because they're not going to get paid anything. And that meant that there was no incentive for salvors to make any effort to protect the environmental impact of a casualty. And beginning in the 70s, but much more elaborately now, salvors do have that commercial incentive to protect the environment. But principally still, salvage is regarded as a hull problem, not a P&I problem. And so that was a long-winded digression to answer your question. As far as I know, hull insurers operate completely at arm's length from salvors, and they just leave it to the salvors. The shipping business is very much a supply and demand. It's very like the sort of pure model of economics. Once it, let me sort of put that a different way. The more commercial traffic there is in the Northern Sea Route, the more likely it is that you'll find salvage tugs available. Not because anybody sort of coordinatedly said this would be a good idea, but simply because the salvors will realize this is a way of making money. Yes?
I want to ask, is there any sort of classific society to issue special classified a special class on those vessels those vessels which operating the Arctic road?
Yes. Yes, just to explain, because I understand the question, maybe not everybody does, what classification societies do, that's another international group of organizations, the International Association of Classification Societies. And classification societies, a little bit, again, to use a metaphor with road, driving your cars around, they're like the people who do your brake tag inspection. They periodically inspect the vessels to make sure that they're in seaworthy condition. They supervise the construction of vessels to make sure that they're seaworthy. And the question was, do classification societies have special sort of tests for vessels going in the north? And the answer to that is yes. Right? There are what are called classification societies have what are called different ice classes, and I mentioned the cost of the ice pilotage and the cost of the permit that you have to get from the Northern Sea Route organization. The costs that you have to pay for the ice pilot and for the permit are different according to which ice class the vessel is in, and that will be the ice class that the vessel is in is a function of, that's declared by the classification society. Okay. Does that answer your question? Yes?
As I understood the albedo map, this is for you, it appeared that the permafrost was retreating rapidly, and the tide of the forest cover was basically picking up where that left off. But it seems like the forest cover was not, it seems like that's just kind of optimistic to me in a way, that the forest is advancing that quickly.
It's not going to advance nearly as quickly. That's a long-term projection. It's much faster for a marine ecosystem to move than a terrestrial one. It basically moves at the dispersal rates of the seeds. So it's going to take thousands of years for the system to really move in there. But essentially, there is no transitional color between permafrost and sort of non-permafrost, eventually boreal forest, but it's not going to move in there quickly.
So how does that change the models, the predictions? Because as a forest sequesters carbon, that's erasing some of the effect of the melting permafrost. But how do you incorporate that into your
That's actually in the models. We look at the rate that carbon is sequestered by the terrestrial systems, but it's actually a net negative because as the permafrost melts, it's actually releasing methane. And methane is a 20 times stronger greenhouse gas. So the permafrost has a huge store of carbon. And as that thaws, that's going to be releasing a lot of methane. So yes, there's some gain by the advancing forest cover, but the methane is another one of these positive feedbacks that there's a lot of concern about.
I have to ask a question. So let me know if this is just what I want to get at is the magnitude. So in Louisiana, we cut these canals through our wetlands, right? And then this had a sort of geometric effect on the loss of wetlands. So this is my understanding. I'm not an ecologist, but is there an analogy to that, an ice breaking or increased transit through the North Poles? Or is that just a sort of order of magnitude, not?
Well, as the ice goes away, I mean, the ice is now thinner than it used to be. So if you do have ice, it's easier to break. So you no longer need the sort of full class 4 icebreakers. You can probably get away with a class 1 or even an ice strengthened boat. So as the ice gets thinner, it also tends to melt back quicker, and the oceans warm up more, so it tends to freeze. So it takes so it's open longer. So I'm not sure if that's the same thing or not. The reason for the canals is different. That it's also to do with when you channel the water, you basically stop these sediments from spreading out. So there's a bunch of different issues with that. But as you, and it's a little hard to say because the ice there is also mobile. So just because one ship is able to go through a route, conceivably, if the first convoy breaks it up, the second one can use it, but the ice pack is actually mobile. So it's not clear that there's a big savings. So I don't think that the density of ships is enough that that they're following a specific track at this point.
Which is why you need ice pilots.
Still,
And it's fairly good ice reconnaissance. The Canadians have had Arctic-based satellites now since at least the 1990s, and they're basically paid for by selling ice coverage maps to shippers. So we know the ice coverage on a daily basis fairly well. When we were up there, we were getting basically daily ice maps, because there's always open water. Even in the middle of winter, there are leads and there are Polinas where there's open water.
The way I interpret her question was, is this area that's opened up by the icebreakers significant in terms of the positive feedback effect? In other words, you have water instead of ice in that area that they broke up.
I'm guessing no, because the density of ships isn't that big there.
Just to interject, remember, 50 a year is a lot in one sense, but when you've got 140 days of the season, that's one every 3 days. That's not a lot of trucks.
Yeah.
Doesn't it freeze back?
I need to stop.
Yeah. Doesn't the ice freeze behind the breaker quickly? I mean, it's my understanding with the icebreakers that it does freeze behind them.
Not in summer.
It goes through.
No.
Not in summer, no.
Yeah, okay. So.
No, once you break the ice, there's basically some inertia on the ice, and it sort of separates. And it's not like one big frozen mass. It tend to be sort of large areas. And in summer, the water is fairly warm, and the ice is basically slowly melting down. So as you break it up, it will hasten a little bit the ultimate breakup of it. But there's just not enough ships up there to make that much of a difference.
Do you have a question as well?
Real quickly, in terms of the passenger ships and their support versus cargo ships, do you think that as the passenger ship activity increases that there'll be more support also for cargo ships, or do you think not? I'm curious, just do you think that their support is more air support than other ship support?
Well, certainly in terms of search and rescue, it's going to be air support rather than sea support, whereas for the hull and cargo, that's all going to be salvage tugs, and the question earlier on is just the more ships use that area, use that route, the more likely it is you're going to find salvage tugs there. But salvage tugs are really, I mean, the principal goal of the salvage tug is to salve the ship and the cargo. So it's property salvage, and for the reasons that I explained before, they now have an incentive to make environmental protection as well. People, salvors, I don't want to give you the wrong impression about salvors, but salvors don't think about people, right? That's not their job. The job of saving people is government job, right? And that's going to be air support. Right? Salvors are not don't regard it as principally their job to have the equipment to save people.
But if I could add one thing, although it said cruise ships, some of those cruise ships are actually converted Russian icebreakers. So
yeah, because some go all the way to the North Pole.
Yeah, so they're really not sort of Royal Caribbean sort of going up, but they're actually full icebreaking ships, which the Russians have realized they can make money from. So some of those are actually capable. They're probably more capable than most of the salvage vessels out there.
Interesting. Well, in terms of like the North Sea and oil drilling with the floating platforms, would you see as the ice melts more floating sort of support stations possible, or as little stop gaps rather than communities?
The problem with floating structures is they still have to withstand the ice in the winter.
Right.
So, and you've got to, the big problem is to position the supplies and the salvage equipment up there. So you're probably going to base out of places such as Resolute right now, and you probably have to build a proper deep water port if you want to do that. But it's hard to see a structure that is permanent up there just because the winters are still going to be frozen and they're still going to be really tough.
Thank you.
Yes.
In addition to the Pacific species finding their own natural path from the warm Pacific waters to the Atlantic waters, is there a concern with increased shipping, non-native species being brought across through the ballast or by the ships? Is that a concern as well?
That'll be the same concern as it is anywhere else, so yes. The difference is they're probably not going to be changing out ballast waters up there because they're basically sealing tanks going through. It's usually as you get close to a coastal area where you're actually changing out ballast. So probably not going to be.
I completely agree. That's exactly what I was going to say. Ships are not going to be deballasting in the Northern Sea route. They're going to be deballasting just before they arrive, or often after they arrive, depending on what the regulations say. So the transfer of species in ballast water is a big problem. I don't think it's going to be an extra problem for the Arctic.
If there's Arctic drilling and eventually production, would they use tankers to transport from the production platform to land-based operations?
Well, it depends on how far off it is, but tankers would be much easier than laying a pipeline, yeah. I mean, pipelines generally are cheaper than tankers in the long run. But depending on how far offshore it is, it's much more likely to be tankers, certainly at the beginning.
Yeah, there's the coastal Atlantic. There's the coastal Alaska pipeline now, and so if it's in the vicinity there, they could conceivably use the Alaska pipeline. And there's some infrastructure in Russia, but anywhere else is really nothing there.
I have a question about ocean acidification, Dr. Drennan. Maybe it's my limited knowledge on ocean ecology, but I assume that calcium carbonate creating creatures are like corals and other little cute sea creatures like that. Do they exist in the Arctic? What is making calcium carbonate in the Arctic that it would be a danger? Ocean acidification.
Pteropods are one of the main zooplankton.
Okay.
So that's the sort of main link in the food chain for pretty much everything else. Sea butterflies is the other term, and they also have a calcium carbonate structure.
What eats those? What's up there? I can't.
Everything eats something.
Arctic cod is the main fish species, and those get eaten by anything from narwhals to seals to polar bears to lots of different things. Yeah, it's a different ecosystem, but it's.
Oh yes, question over here.
Is that ship specially designed to be able to freeze in?
Yes and no. Again, there's usually open water up there. So it's an ice strengthened. It will do some ice breaking. I think it's not the full ice breaking strength, but I was in it when it was doing some ice breaking. But we spent the time basically looking for leads, which is sort of open longitudinal cracks and empolinas, and we were in those most of the time. There's a helicopter, so when you're basically ice breaking, you've got someone in the sky for eyes looking for thin areas. Conceivably, it can get bad enough, it could get stuck. It's not a full-class icebreaker, but it's designed for the Arctic.
I was thinking about, you said overwintering.
Yep, it was up there. The most difficult thing was having to pre-position all the supplies for the season. They actually had to bring in barges for things like fuel, because there is nothing up there where we could get fuel from. So that was all done. Yeah, so it was 14 months. It was, there was times when it was locked in ice, but for the most part, it would seek areas which were thinner, open water.
Question here. Nate.
I'll make it quick. Going back to the two passages, the Northern Sea Route and the Northwest Route. You mentioned they save approximately about 3,000 plus minus miles on each route, but then in terms of the ice breaking and the speed and the time at which it is done, how viable is that compared to?
It's net. It's definitely net cheaper, right? Because the things that you have to factor into the comparison are you're saving the canal fees, you're saving things like stiffening going through the Gulf of Aden, but then on the other side of the ledger you're paying much less for bunkers. On the other side of the ledger is the cost of the pilotage, the per cost per transit cost of things like the insurance. But the net expense is less. And the only reason that not more ships are doing it is because, well, first of all, it's seasonal. And one reason, I mean, the statistics I showed only one container ship did the Northern Sea Route, whereas lots of tankers do. And one reason for that is container ships usually follow the same route over and over again. They're liners. Well, you can't do that using the Northern Sea Route because it's only open for less than half of the year. Whereas ships that work on the spot market, like tankers that are taking cargoes from one place to another all over, that is it's viable for them. So the net cost is definitely less, but for the reasons that I tried to explain, and we both tried to explain, it is more hazardous, which increases the insurance cost, which is why I talked about insurance issues.
I got one question. So at what point will the insurance industry take into account the changing ice and actually reduce the premiums going through the Northern Sea Route? Because at some point, they should admit that there's less of a risk than they thought.
Right. And I laugh because I said earlier on, we often like to make fun of economists and, the model of the perfectly responsive market. But if there is anything like the perfectly responsive market that economists, like assume a can type thing, it's very close, the way the shipping business works. So the less risky this becomes, they'll be responsive because some insurers will then start charging less. It's a very competitive business.
All right.
Time?
Thanks, guys.